Okay. Awesome.
Hey everyone,
Guys,
welcome to Forecasting Google Trends Data with R. Welcome, welcome.
to join. Art is an awesome language that hopefully everyone will soon get really excited about.
And everyone, as you join, feel free to start writing in where you're joining us from.
We want to know who our audience is. Hi, Melissa.
Hey, Kenneth from Michigan.
Oh, salut de Montréal.
Ooh, Montreal, French. We have...
Wow, all over the world. This is so exciting. Ah, de Brasil, gente.
Israel, Lebanon, Argentina.
I love this.
All across the states. Good afternoon or early evening to you all in Europe. Vietnam, so good
Whoa, Kenya, nice.
morning, later at night.
Oh, this is awesome. How is everyone doing today? Are you guys excited?
Yeah.
Going to the world of data science?
We're definitely excited over here, and we are coming to you live from New York.
Woo!
Normally, we are at the Codecademy Soho office, but today we are both coming straight from our homes, as I'm sure most of you are as well.
But we are going to make the best out of this situation. And one thing that you can do from home is learn and program and code. And Kayla, we will be learning R. And not only will we be learning R, we're going to be doing some time series analysis and some really cool forecasting, really the bread and butter of a lot of our predictive analytics. So I think I'm very excited.
It's going to be a great time. And if you've been joining us all day, logging some of our other sessions where we've been talking about a little bit of web development or learning other languages, this session is going to be a little bit different. We're going to go in the direction of the data, which is something that Camelia and I both really love. And we'll be showing you some really cool things that you can do with data science. And we'll start off with a little bit of on-platform and the Codecademy environment, which you might be familiar with. But we'll also be venturing off-platform to see what it's like coding on your computer. Hello, everyone. We'll wait another maybe 30 seconds or a minute or so to let everyone come in. So we have a question from Maria. Do I need to download R? So for this session today, I would recommend that you go ahead and just follow along with us to see what we're able to do with R. We'll spend some time on Codecademy where we welcome you to follow along with us if you'd like. But when we go off platform into our own environment, I will be showing you some cool things that you can do. And we recommend just watching along, asking questions as they arise, asking why we're doing certain things or what else we can do with coding and data science. And then you'll have the opportunity afterwards to go off platform, download R yourself, and try and explore it and perhaps do a similar analysis to what we do here today.
And I think the biggest thing for me, just because I have been a data scientist for some years now, is I wish I had the opportunity to have someone like Ian, who's going to be able to walk us through the code, and who's just going to get you super familiar with R, super excited about a lot of the statistical methodologies that we're going to go in together. And then I think the biggest thing is just don't be scared, go into Codecademy, play around with the learning environment, get familiar with all the functions. Like R might become your best friend. You may not know it yet.
And we have another great question from Vatsal. What is R? Great question. So R is magnificent and amazing and fun, and it is a programming language. And the cool thing about R is it is a statistical programming language, so it's designed to work well with doing statistical analyses or doing data analysis. So it's great for taking in all that data that is being collected all over the world about every single topic and letting you find interesting insights or maybe creating visualizations and ultimately trying to find answers that can help us make decisions about the world.
Ooh, I am loving these R versus Python questions and R versus JavaScript questions. And I just really want to answer it because I think as a data scientist, it's really these very diverging philosophies, right? Like, do I go for R? Do I go for Python? I would hardly say that any data scientist is trying to get their hands dirty with Java or JavaScript, but that's mostly just because it's way more complicated. It's actually an object-oriented language. However, what I will say is that R is super easy to use. It was actually built by statisticians for statisticians. And that means that people like analysts, data scientists, sociologists, economists, whatever, don't necessarily need to have the most, I would say, strongest foundations in computer science. You can just go ahead and learn R and within a few lines of code, be able to develop an analysis, even develop a machine learning model. So that's why I highly, especially if it's your first programming language, definitely go for R. The learning curve is just so much easier.
And similar to that, we're seeing some questions about what exactly is data science, and do I need to have any prerequisite knowledge going into this today? Should I know math? For today, we want to just spend some time showing you what are the possibilities with data science. And data science is essentially just taking some data and doing something with it, organizing it in a different way, formatting it in a different way, so that we can find out some new information or recognize some patterns. And so you don't need to have any background in programming or math. We'll explain things along the way. And we just want you to be thinking about kind of what is the bigger picture? What are we finding out from our analysis? And what does it mean for our lives or for our interests or for the world or even for you personally? So no need to fret if you don't have that background. We'll be taking you hand in hand today.
So that being said, Ian, should we start? Since I think people are almost done coming in, we can start with some intros if you want to kick it off.
Yes, let's do it. So hi, everyone. Welcome to our session today on analyzing Google Trends data with R. My name is Ian Freed, and I am a senior curriculum developer here at Codecademy. And so what I do in my job is spend a lot of time working on designing the courses that go on the Codecademy website, specifically related to data analytics and data science. So in the past, I've done some courses on machine learning, which maybe you've heard about, or natural language processing, which is where we're looking at text data and trying to get some insight into that kind of data. I've also worked on creating our Learn R course, which I will recommend as a great entry point to programming as well as to data science. So after the session, feel free to check that out and give it a go yourself. Really excited to be here with you all today to learn a little bit about R, check out Codecademy, and then do some data science.
Cool, thank you, Ian. So hi guys, my name is Camellia Hassan. I am a data scientist at Codecademy, and I've been a data scientist for quite some time now. I just moved to New York, and before this, I was a data scientist at Uber, where very similar to what I'm doing at Codecademy now, I was building out experiments, designing some causal inference frameworks, rebuilding machine learning models, which is always fun in the space of risk and safety. So I'm very, very passionate about data science. I think like a lot of you, I'm a total math, physics, statistics nerd. And I think for people who have these types of affinities, this is a really amazing field to be in, just because once you have basic understanding about a lot of these, core methodologies, you can go ahead and apply it to any type of industries, may it be operations, ride sharing, logistics, healthcare, finance. I mean, you name it, the world will always, always need data scientists. So that being said, we have a really incredible agenda today. So I know the title of the course is Forecasting Using Google Trends with R, but before we jump into that, we're actually, as Ian mentioned, we're going to go into the learning environment, and we're just going to go and do some really basic foundations of exploratory analysis, try to figure out how to manipulate data frames. And I think once we are able to do this, we can actually get our hands really dirty and get into the code. So once again, it's very interactive. If you have any questions while we are in the learning environment or at any point, just chat us, I'll be monitoring. And then, yeah, I mean, overall, R is just, once again, I couldn't say like, such a great and easy and fun language. It was built by statisticians for statisticians, really with the main purpose of data analysis. And of course, you can do data analysis in Java and in Python, but R is just so easy. And for me, like examples of work that I do using R is just any type of exploratory analysis where I'm looking, am I looking at a normal or at a Poisson distribution? When I'm doing hypothesis testing, if I want to compute a power, R has some packages within one line. I can look at the sample size estimates. So I couldn't recommend it enough and today really we're going to be doing it, some time series analysis. So we would love to know, time series analysis, have you done it? That being said, Ian, let's go into the LE. Let's have some fun.
Definitely. And you should see also in the Zoom, there is a poll going right now where you're able to answer some questions about your familiarity with R or with time series analysis. So make sure you're going ahead and answering that poll question. It seems like we have a lot of people who are new to R, haven't worked with time series analysis before, which is super exciting. We're going to take you on a great journey today. So I'm going to go ahead and start sharing my screen so we can go jump into the learning environment and take a look at some R together. And now, as I jump into this, let me say, before coming to R, I know a lot of you are asking these Python versus R questions. I was a Python person. That's what I started out learning when I got into data analytics, data science, and it was what was first introduced to me, and I grew to love it. But then about a year ago, I started working with R for Codecademy. And it's been a really great journey as well. I now am a huge fan of R in addition to Python. So it's what I want to let you guys know is that it's not about one language or the other. It's about which tool is going to help you accomplish your task. And when it comes to data analysis and data science, Python and R both really steal the show. So you can't go wrong with either of them.
I just want to give one example because I know everyone's freaking out about this R versus Python, which is always super exciting. But I can give you a really quick example of in one case where you would use Python versus R. I think really once you become like a full stack data scientist, which means that you're building machine learning models and you need like real-time pipelines. So you're basically needing pipelines to predict things every second, every minute, and there is like operational needs, then yes, I think Python is definitely more powerful than R. However, we will not be doing that today. And to be honest, like that just takes a lot of time, a lot of effort, and you can still do so much cool work with like what we're going to be showing you right now.
Definitely, great point, Camelia. And on the other end of things, there are some things that R can excel at in some people's opinions, one of which is often data visualization, and we'll be doing a little bit of that today. So we'll get to see some of that advantage that we can get from R. So in order for us to get to that though, let's dive into the learning environment. We're here on our introduction to data frames in R lesson. And in this lesson, which we really recommend that you take some time to go through after the session, over the weekend, and any of the free time you have in the next coming weeks, and learn about how we work with data in data science. And we often load our data into something called a data frame. And a data frame is essentially like a table that you might see if you're working in Google Sheets or if you're working in Excel, where we have rows and columns. And from this table-like format, we're able to go ahead and do a lot of interesting analysis. So it's a good foundation for us to work off of. And so in this lesson, you learn all about data frames. And I just want to spend a little bit of time going through what this lesson looks like if you're coming to it for the first time, and how we can take advantage of the power of R. So in this lesson, we have our code editor, right? So if you've ever worked with Codecademy, we often have some content on the left side of the screen. We have a code editor in the middle. And then on the right-hand side, we have our browser component. So this is where we're going to see the output of our code in this case, since we're working with an R notebook, which is a really useful kind of file where we're able to write some code and then have it display in a rendered HTML page. So it really adds some like dynamic ability to your code. And so we can see right now when I try and run this file, nothing is happening. We're getting some errors and our code isn't working as we'd expect. And the reason for this is we are using some R packages, which are really useful collections of code that other people have written that accomplish tasks for us. And that's one of the great parts of R is that there are all these packages out there of people who have spent time and research figuring out how to accomplish different data science tests. And they've gone ahead and put all of that together for you. So you don't need to write all of that code by hand. You can just use these packages. But we're not loading that package into our code file right here. So what I'm going to do is I'm going to load two really helpful packages right here into this code block. And so we can see a little code block is defined by a few backticks, so 3 on the top, 3 on the bottom. And in here, I can write our code. So what I'm going to do in here is write library, and I'm going to put the R packages I would like to load. One is called the reader package, and one is called dplyr. And these packages are part of a greater collection of packages in R that we call the tidyverse, which is a collection of packages that are super helpful, super useful, and enable us to do a lot of these tasks that we want to go ahead and do. So now that I've written in here to go ahead and load those packages, I'm going to click the run button so we can run our code. And voila. Amazingly, now our code that we had written here is displaying all of this information on the right-hand side. And so let's go ahead line by line and see what is going on here so we can go through together. So after I load these packages on lines 8 and 9, we load our data into a data frame. And so what is this data that we're actually working with? We can see that there is this file artist.csv, which is a CSV file, which we can open up right over here. And you might have seen CSV files at work or at school. They essentially contain that same kind of data that you might have in a Google Sheet or an Excel spreadsheet. And in this format, it's a little bit hard for us to read this data. I can look at it and I can see some band names from around the world. I'm a huge music fan, huge music lover. So I love working with music data. And that's, I also think one of the cool things with data science is you can find data about any sort of topic that really interests you. So I went ahead and chose some music data for this lesson. And we're going to take that CSV data and use a function from one of our packages called readCSV to load it into a data frame that we're naming artists. And in this next code block, we're using a few different functions to go and look at that data in the data frame. So right here on the right-hand side, we can see our artist data frame has a few different columns. One is group, which looks like to be showing a group name. We have a country representing the country that that band is from, as well as the genre. And if we click over, we have a few columns representing streaming numbers. So we have Spotify monthly listeners, YouTube subscribers, year founded, and the number of albums that that band has created. So we have a few different columns here of data. Some of these columns contain what we call in coding a string, which is text data. So for the band name and for the country, those are strings. Other columns represent some numeric data that we have. So like those listeners or the year founded. And so we can use a few different helpful R functions to inspect or analyze this data frame, one of which is the head function. So that goes ahead and just grabs us the first 5 rows from that data frame that we have. And then, or for 6, excuse me. And then we also have our summary function. So the summary function, which is on line 21, is able to give us some information and statistics about the columns of our data frame. So we can see here, we have the min value, the median value, the mean. And so it's providing us some quick insights about our different columns that we have. One last code block that we have here in this notebook file. We're doing a lot of stuff here. So I want to break it down with you line by line. And if anyone has any questions, feel free to put them into the chat about what's going on, and we'll make sure that we can jump into them. So we're taking our artists data frame that we have, right? So that's that same collection that we had right up here. And we're going to use some functions from dplyr to filter and break down and see what's going on inside of our data frame. So first, we are going to use a function called select. And what the select function does is it says, let's only look at certain columns of our data frame. So some of them are important to us, other ones aren't. So in this case, I'm telling on line 27 that we do not want to see that country column, the year founded column, or the albums column. Those aren't important to me. We're going to take them out and remove them.
And really quick note, because I see a lot of people were also asking about how R relates to SQL. And for those SQL lovers, you'll see that their functions select is very similar. So you can really just think of that block of code from line 26 to 30 as a really long select from where function condensed in R syntax. So there's definitely a bunch of similarities, and actually for those who started learning SQL and then are moving to R, it's a really easy way to put things into perspective.
Definitely. Before I ever knew R or Python even, I had that background with SQL. And so I had learned those select, from, ordering by, and a lot of those same concepts filter on right over to R. Now let's talk about another function that we can do in R that is similar to a SQL statement, actually. So in SQL, if you've worked with that, we can use a where clause, where we say we are looking for rows that have a certain value in a column. Well, in R, we can use our filter function. So in line 28, we're using a filter function, and we're saying, let's only take the rows of this data frame where the Spotify monthly listeners is greater than this number, which is, I'm checking right now, 20 million. So if we have any rows where the number of Spotify monthly listeners is greater than 20 million, we want those rows. And we're also gonna pass another condition, that we only want groups that are not in the genre of hip hop. And so in this case, I could have said, I only want groups that have a genre of rock or a genre of electronic, but here we're specifically saying we just want any group that has the Spotify monthly listeners greater than 20 million, but a genre that is not hip hop. And then on our last line, also going back to SQL, if you're familiar with that order by clause, here we're using the arrange function. And this says, let's order or arrange the rows of this data frame by certain columns. So in this case, we want to order our data frame by the number of YouTube subscribers, but we want to do it in descending order. So that means going from the greatest value to the lowest value. So if we take a look at what that code looks like when we've run it, we can see that we now only have 3 rows, 3 groups: Maroon 5, Imagine Dragons, and Coldplay. So if we have any fans of these groups in the chat, feel free to shout it out. We can see that these are all rock bands. Rock is, a pretty universal, popular genre all across the world. And we can see they all have Spotify monthly listeners that are over that 20 million number. So we can see here, since we're arranging by number of YouTube subscribers, that the band that has the highest number of YouTube subscribers, which is 240,711,114, is Maroon 5. So it seems like they are our big popular band. So I see Elle pretty happy about that. I'm glad that your band that you love is being represented.
Coldplay is number 3, Corel.
And Coldplay, number 3. And I see a great question in the chat from Evelina. What exactly does the pipe operator do? And so the pipe operator is this funky looking symbol right here with a %sign, a caret, and a %sign. And this is something that I think is pretty unique to R, and specifically to the tidyverse, which is this collection of packages that we're working with here. And if you're familiar with programming at all or have any background or experience, typically when you're using a function, you will pass in a variety of arguments. So for example, with this select line or select function, we're saying we don't want the country, we don't want the year founded, and we don't want the albums on line 27. And typically we would also, as a first argument, directly pass in our artist data frame right here. So if we wanted to just do this in one line like this, we would write something like that with artist as that first argument. But the pipe symbol enables us to write code in a way that I think makes a lot of sense and is helpful when you want to do multiple or use multiple functions in a row. So in this case, I want to take the artist data frame and I want to select certain columns from it on line 27. Then I want to filter on line 28, and then I want to arrange or order them on line 29. And so this pipe operator is allowing us to basically say, let's do that selection on line 27, and then take that selection and now use the pipe to send it to our filter function. And once I do that filtering on line 28, let's use the pipe again to pipe that filtered data frame into our arrange function. So it lets us write our code in a sequential order that you traditionally wouldn't be able to do. So great question, Evelina. Awesome. So this was a nice little quick jump into the learning environment, into R, but there's so much more that we have in store for you all today. And it's going to take us venturing off platform, venturing to other parts of the web. So if you want to circle back to our Learn R course, we highly recommend that you do that in your free time after the session later today or over the weekend, and check it out for yourself. It's a really easy start to your programming journey, and I think you'll have a lot of fun.
Cool. So yeah, just another, we did everything in like one lesson, but if you actually take the time to do the lesson, you'll see that it'll be broken down. So, you know, a lot of people are like, what's a piping operator? There will be, you know, like one lesson specifically on that, and then another one on like select and, you know, understanding tidyverse. So I think like if you take your time, you'll be able to just break it down more and have a deeper understanding of what's really happening in terms of the language. But now it is time to get into some forecasting using Google Trends. So I think before we jump into the code, I want to talk about Google Trends. So Google Trends is going to be the data source that we will be using today. I'm going to have a quick voiceover, but you'll see Ian on the Google Trends website. And for those, all of you online, feel free to kind of get on that website and play around. It is an amazing publicly available data set. And really for those who are unfamiliar with it, all that it measures is relevant hits and kind of all of your search queries. And it's not just of me or of you, but all over the world. And I think what's really great about Google Trends is that you're able to look at it from like as a total time series. So let's say if I were to search sushi, I would be able to see how the hits of sushi, guess I'm getting hungry, has changed over time. And then another cool thing is that I can actually even compare things. So especially these days, you're feeling a little bit bored, you can compare, well, how is sushi and pizza doing across in the last 5 years? And so really what it's going to do is going to take all of those queries that all of us in the world have queried for, and then just be able to compare the interest over time. Now, Google Trends can compare only 5 things at a time, so we'll have to we'll have to brace ourselves. And then you can also look at it not only from a time series perspective, but you can look at it geographically, by category, interest by region, interest by city. So super, super interesting data sets. And one of the reasons actually that there's been a lot of papers published using this data sets is that there is a hypothesis that there's a very strong correlation with the actual level of activity or, kind of interest in that actual matter. So, if depending on whatever like application you're looking into it. So in this case today, we're going to be using Google Trends. And what you'll see is that there's a fantastic R package and R function that just takes that data and will be used for our case today to analyze. Now, forecasting. Forecasting is one of my favorite topics in data science. And I think it's something, it's not a person, but it is a thing that all of you have had exposure in one, you've probably learned about it in your statistics class. You've heard about it in terms of weather forecasts, electricity demand, sales, customer support tickets. These are all things that you can forecast. And that's what we're going to be doing using the Google Trends data set. Now, how are we going to forecast? I wouldn't be freaking out right now if none of you have, haven't even taken a intro to statistics course. That is okay. Because the really cool thing about forecasting is that there's so many methodologies out there. There are some really naive ways to do forecasting. Sometimes you can just really take the mean of your historical time series and use that as your proxy for a forecast. Or sometimes you can literally take your last observation and whatever you see in your data set, that would be your proxy for your forecast as well. Today, we're actually going to be doing something more complex, but actually be able to deliver it in such a simple way using the Profit package. I know it has a very glamorous name. So for those of you who haven't heard about Profit, Profit is a library. It is a package that is created by Facebook. Now, what does Profit do? Profit is essentially a forecasting, it is a forecasting package that any one of us have access to that we're going to teach you how to install and that you can apply to your data set. And now the really cool thing about Profit is that you don't necessarily need to have like some really deep understanding on regression models or like complex statistical methodologies. All you need to do is really understand what is it trying to extract. Yep, I'm slowing down, guys. Sorry, this is me getting so motivated. So it's something that you just need to understand what is the seasonality, what is the trend, and then you apply Profit to your data set and it will apply the forecast. So I understand I spoke very, very quickly, and do not worry, we are gonna go through this with the code, and I think I will be able to reiterate it once you guys see it in real life. So that is all from me. Ian, take it away.
Hold on one moment before, I don't know if we want to, while transitioning or before transitioning, take a moment to get to some of these great questions that we have open right now.
Yeah, great mention, Elisa. And so I'm looking through some of these right now. So
Okay.
Jeff is asking, when working in data science, what percentage of time is spent scrubbing data versus analyzing data? So you can ask this question to a lot of data scientists or data analysts, and you'll get a variety of answers. But there is a lot of truth to this idea that so much time for an analyst might be spent on cleaning or organizing data and getting it ready for that analysis phase. This can depend on the environment that you're working in. So there are some organizations or companies where there's good data infrastructure and these data cleaning tasks maybe aren't as time consuming. But I would say from what I know and what I hear, there can often be a lot of time doing that cleaning and organization, which in my opinion can be a ton of fun. I really enjoy it. It's a cool part of doing data analysis. But you do also get to spend a lot of time doing that actual analyzing or building models or interpreting your data too. So I would say that most jobs have exposure to both of those sides of the role. Camelia, would you agree with that?
Yes, I would, and unfortunately, it's one of the it's one of the activities of a data scientist that we enjoy the least. It's really cleaning the data, and there's always a basic kind of, I want to say 60-40 rule where you have to spend 60% actually getting the data, tailoring it, trying to make sure that it's reliable, doing a bunch of QA, and then getting it to a format where you can then actually do the the really cool analysis and modeling. Yes, Joe, I hate cleaning data. It's really not my specialty, but we all have to do it. Unfortunately, it's part of the job.
So some other questions we see here. Oh, this is a good one that maybe Camelia, you can chat a little bit about. We have a question from Stephen asking, is a forecast and a hypothesis the same thing?
Ooh, that is a very, very good question. So actually, this is what your question is actually very smart in the sense that you need to have hypotheses. First of all, as a data scientist, as an analyst, always come prepared with a hypothesis. You need to have an intuition of what's happening and what's driving the data, right? Once you have an understanding of what's actually happening and what does your data look like, then you're going to have a bunch of assumptions that you're going to have to give. And that's what makes really the job of a data scientist irreplaceable, is the assumptions that you're putting and you're applying to your data set. And so that's going to be able to really kind of configure the forecast that you use. And so right now, and we'll definitely dive into this when we look at our application, we're going to have to apply a bunch of assumptions to our forecast that thankfully Prophet is already going to apply. But you will be able, depending on the data set that you use in future use, and depending, of course, on the hypothesis, you'll have to configure as you see fit.
Great question. And then we also have another question about what is the difference between forecasting and predicting? And can these terms be used interchangeably? So I would say that a forecast is a type of prediction. We hear this word prediction a lot in data analysis, data science, and a prediction can be one of a variety of things. Maybe we are predicting the type of user if we're looking at a bunch of user data. So what is maybe like the characteristics of this user, or maybe we are predicting a house price based on a variety of factors such as number of bedrooms or the bathrooms. But a forecast in itself is a prediction of a future value of something that we are analyzing. So that was a great question. And so basically forecasting can be or is a prediction, but prediction can mean a lot of different things.
And the thing is that, as Ian said, forecasting and predicting uses basically the same, they are essentially tied together. The methodologies that you use for forecasting, such as regressions, those are the same methods that you're going to be using in any type of machine learning and doing a logistic regression and doing a linear regression. So definitely, forecasting is part of the modeling and predictive analytics world.
Cool. So we have a few more questions. I'm seeing a few about the tidyverse. And as we jump into our code in our studio, we'll chat a little bit more about that there. And so I think we'll move forward into this next step so we can get our hands dirty on a little more code. And we'll circle back in to answer some more questions in a bit.
And I will be monitoring the chat and the Q&A. Apologies if I don't get to everyone, but I will focus on you, I promise.
Yeah, we love all your questions. Thank you so much for being inquisitive. That is one of the, I think, really defining characteristics of a data analyst or data scientist is asking questions. Asking questions about the data, where the data is coming from. If you have someone who's telling you to look at the data and do some insights, you should be asking that person questions. Why are you interested in this metric? What assumptions are you making about the data? Why are you interested in it? Asking questions is really one of the greatest tools that you have out there. So keep it up, everyone.
And as Ian logs in and starts working in R, I'll give you guys a fun fact. I remember when I was a kid, everyone was always telling me, Camelia, you're so curious. You don't need to know that. Stop asking questions. And well, joke's on them. I guess now this intrinsic curiosity is really helping me in my day-to-day.
Definitely. Cool. So I've switched over to RStudio, which is an interactive development environment for R. And when you're going and getting started with R, use Codecademy, check out our lessons. It's a great playground for exploring. But there comes a time with most programmers when they want to go and start coding on their computer itself. And RStudio is the best way on your local computer for you to go ahead and do that. And so throughout this session, we'll do some exploration of RStudio, show you how to run code in here, utilize some of the features and functionality, and you'll see that it's a really great tool for writing code in R. And on Codecademy, we have access to a video that will go ahead and also show you how to work with RStudio that you will have access to temporarily as a part of this whole session. So feel free to check that out. Awesome. So let's go ahead and get started with doing some analysis on some Google Trends data. So people were asking about how do we work with the tidyverse? When in the example, we were only going ahead and loading in dplyr and reader. So reader and dplyr are part of the tidyverse. So we can use our library function to load that package explicitly by just saying library with dplyr or reader as a argument, or we can just use tidyverse overall. And this will automatically load for us all the packages in the tidyverse. So there are a lot of them out there. This can be a simpler thing to do when you're working locally, and we'll do that here. In addition, there are a few other packages that we're going to use here today that I'm going to load right here at the start for us. One is called Lubricate. This package is really useful for working with date data. So it's a kind of a play on the word lubricate because it makes working with dates easy. I like that one. There's lots of punny names with R in the R universe, so I always enjoy that. Another package we're going to be using is gtrends-r. This package enables us to go and search Google Trends for the specific search terms that we want and get that trend data. Additionally, we're going to use the profit package, as Camelia was mentioning, created by Facebook.
Sorry, Ian, Kara is definitely right. Did you misspell tidyverse?
Yes, thank you. So I do this all the time. I misspell things when I'm coding. And then I go ahead and run my code, which I'm going to try and do right now. And we're going to see I get this error. So thank you so much for calling that out. I'm going to go ahead and update this to tidyverse. And now when I go ahead and run the code in just a second, we should see no errors or issues. Don't worry about sometimes spelling things wrong. It happens when you're coding. Happens to me all the time. Thankfully, we have errors which help us guide us in the right direction. So great call out. And then one last package we're going to use is the maps package. And this package will enable us to do some visualizations with maps, which are, I think, really fun, really useful. We're seeing a lot of these visualizations today with the ongoing COVID-19 situation for visualizing cases and things like that. So we'll do a little example of that here today. And so in RStudio, I'm able to run a code block using some keyboard shortcuts. So for anyone out there who does work in RStudio or is going to get started with it, that's Command-Shift-Enter, and I'm able to run that code and get those packages going.
Sorry, one more comment. I think there's some confusion. How do we follow along on this? So I think this is a little bit different from what we did previously in the LE, where you guys had access to the learning environment and could run it on your own. This is what we're going to be doing right now, is just showing you how to use this code. And so just really all you need to do, to be honest, is just listen and look, and then we'll be providing the code so that after you can go ahead and play around with it and run on your own. So really all you need to do is just listen and learn.
Yeah, and at the end, we will share this file with you. So you're able to go ahead, download RStudio yourself, and then play around with the code or run it in your own environment. But like Camelia said, just sit, listen, and feel free to ask questions along the way. And we'll be asking you some questions too to get some audience involvement. So let's go ahead and get that Google Trends data. So we're able to do this using that gtrends package, and we're going to use a function called gtrends. And this function, if we want to get an idea of how it works or what we need for it, we're able to go ahead and use a helpful feature of RStudio, which is this help feature. So if I just put a question mark in front of a function, I can go ahead and do on a Mac Command-Enter, and you'll see in this bottom right-hand corner, it brings up the documentation for this function. And documentation, as I'm sure you may have heard from people, is a really important part of the coding process. documentation is essentially instructions that were written by the creators of packages that explain to you how to use the different functions that they're using. They tell you what kind of data you need to put into it, what you get out of these functions, and overall, it's really helpful when you're trying to go and write some code. So we can see here that this gtrends function as arguments takes a few things that we're going to use today. And we're going to use the keyword argument, the geo argument, and the time argument. So the keyword argument represents the search terms that we want to use. So before we searched for sushi and pizza, but this time we are going to search for a few different programming languages. And so today we're going to focus on two that you might have heard of, Python and Java. So in addition to providing to gtrends which terms we want to take a look at, we're also going to provide another argument of geo. And the geo argument represents which geographic region we want to focus on. So in this case, for today, just to make our analysis a little bit easier, we're going to focus on the US. So we'll be looking at different interests in the search terms Python and Java throughout the US. Lastly, we're going to use this time argument in order to limit our search to a specific time period. And so we want to look back from today, so this current date, and then go 5 years into the past. So this +5 is saying, let's go back 5, and then the y is saying 5 years. If I was only interested in going back 5 months, I could change this y to an m. If I want to go back 5 days, I can change it to a d. But we want to go back all the way to 2015 and use y. And I want to save the output of this search to a variable that I'm going to call lang. We'll go and run this code. Ooh, it says I'm getting an error. And what is my error here? So, let's see if I take out this keywords. I think it might be keyword. We'll give this a shot. There we go. So misspelling my argument name there. But we have to give this a little bit of time to load because what the gtrends.r package is doing is it's going to Google Trends, searching these terms for us, going back 5 years and storing it in our lang variable. So let's go ahead and take a look at this variable.
And by the way, guys, when you do have access to this code and start playing around with it on your own, have fun with it. Change the parameters. Like if you're from Kenya, look at like the different trends on different top searches. If you're from Brazil, like look at what's been happening in like forests versus, you know, anything else. Be creative. These are the things where really you'll just become a total expert in whatever data set that you're looking at.
And that's a great point, Camelia. Another thing of data science that I was touching on a little bit before is kind of the topic or the domain of interest. And so we're talking about programming languages here since we love programming. We work at an educational technology company. It's something that we're passionate about. But let's say you're a sports fan. You can feel free to update those keywords to different sports. Or if you love food, different food options, or video games, you can put in popular video games here. Whatever your interest is, feel free to go find data related to that. I think it's one of the really interesting things about data science is being able to dive into whatever it is that excites you.
One of the fun things that you guys can actually do, because I'm sure that all of you will want to go on vacation after this, you know, this era, you can go ahead and be able to use this code to like look at different top holiday destinations and then like predict how popular those holiday destinations are going to be. So you can figure out, you can do some price wrangling and figure out what will be maybe the cheapest ones. Those are just some ideas. I mean, you could literally spend hours on this. Once again, total nerd.
Totally. So many options, so many ways you can go. So when we're looking at this lang variable, we can see it's spitting out all of this data. And so this data looks like those data frames that we were looking at before, and that would be a good guess because they are data frames, but we're getting multiple data frames here. So we have a lot of different data. And so we're able to go and get an idea of how is this data organized by quickly looking at the the names of the different data frames that we have stored in here. So I'm going to pass our lang variable into this names function, and it's showing us that we have all these different data frames. One is interest over time, and this is what we'll be using for that time series analysis. We can also look at interest by country or interest by region. And if we actually looked at interest by country here, we would find this data frame empty because we were only searching on US. But if we did a global search, we would have all these different countries here and could do a cool analysis. But for today, we're gonna just go and quickly look at interest by region as a quick start. If we do lang interest by region, and when I start typing in a name of one of these data frames, we can see it pops up automatically as a different option. So I can click interest by region. And the way that we access that specific data frame within lang is we use this $ operator. So we're saying within the lang variable, let's go grab that interest by region. And now I'm going to use our pipe operator. Let's try and take a look at the regions that are most interested in Python. Let's say that's something that we want to get out of this data. And actually, before I do this, it would probably be helpful for us to take a look at this data really quickly. So I'm going to show that right here. Interest by region. So let's look at this data. What do we have here, right? It's easier for us to decide what analysis we want to do once we see what we have. So we have a column location that represents different states. We have a hits column, which is representing that Google trend popularity. So that's what is that interest in this topic. So 100 being the highest, 0 being the lowest. Then we have the keyword. So that's the actual search term of interest. And then we also have a few other columns. So we have the geography, US. But we're not going to worry about those for right now. Let's just think about that hits and the keyword and location. So if I wanted to see which states are most interested in Python, what I can do is use that pipe operator and say, let's filter this to only show the rows where the keyword is, and I could choose here either Python or Java. So let's say I want to look at Java. I will then use our pipe operator and then say, let's arrange these rows by keyword in, by hits in descending order. So this is saying in descending order, right, the rows that have the highest value for hits with the keyword Python. And I only want to see the top 10 rows. So I'll use this head function that we were mentioned earlier, which just grabs the first number of rows in the data frame that you ask it to. So if I pass in 10 here, it'll grab us just the first 10 rows. And if we go ahead and run this, we can now see the states that have the greatest interest in Java. So at the top, we have Washington and Virginia. So we have one West Coast state, one East Coast state. And then we also have Massachusetts, California, Maryland, wrapping out that top 5. And really easily, if I wanted to go ahead and just see what is the most popular states for Python, I can just go ahead and change that keyword to Python, run my code, and now we have the states where Python is most popular: Massachusetts, California, Washington. So it seems like Massachusetts or Washington, big coding places. And this is one of those things that I think is really fun. It's to think about why are maybe people looking up coding in these places. And a way that we can dig into this a little bit further is let's go ahead and change the data frame really quickly. Instead of looking at our data frame interest by region, let's change this to interest by city. So it's going to be a very similar analysis, but instead of the location being a state, we're going to see it by city. I'm going to run this.
Ooh,
and we get some interesting results. So the most popular place for city for Python is Mountain View. I don't know if anyone out there knows if there's certain companies that are based in Mountain View. Maybe that has to do with it. Maybe there are some Googlers that are out there searching for Python, but that is a possibility. So these are the kind of insights that can be fun to search into when you're kind of looking through a data frame to see what you can find.
And so, and going back to that question about, hypothesis testing, I think this is like really the power of exploratory analysis, right? Once you start looking at these different types of distributions by city, by country, by region, then in whatever, in whatever industry or framework you're in, that's when you can start building out these types of hypotheses of like, oh, well, is there, are people more interested in Python or overall in programming and in Mountain View than in anywhere else in the world? Well, what are the things that we can do to test this out? And how is that going to affect our forecast? So really, that's the point of these types of exploratory analysis.
Great point, Camelia. And we have a good question from Rachel. Are the list of hits normalized to 100? And so this hits column is representing relative interest. So basically what it's saying is, yes, we're kind of normalizing from 0 to 100. So it's looking like over, like in a relative manner, right? Like where is this language like most popular or least popular? So yes, it is in that kind of fixed range, 0 to 100. It is not like exactly 100 hits. There are, I'm sure, more than 100 searches for the word Python from Mountain View. Great question, though. I mean, that's something that you'll see in data a lot. Maybe we're normalizing variables, which might mean we're changing the range that they go over in order to aid in our analysis. Cool. So now that we've done this little bit of exploratory analysis on our data frame, it can sometimes be helpful to make a visualization to showcase what we're talking about. So it's one thing to look at a list of places where something is popular, but if we have that visual it can be a little more intriguing or interesting. So let's quickly go ahead and make a visualization that will showcase where certain languages are popular by state. So we're gonna go ahead and I'm gonna write some code quickly to do this for us. Essentially we're gonna map this data to an actual map of the United States. So I'm gonna use this map data function from the maps package, and I'm going to pass in state here. And what this is doing is it's grabbing the actual latitude and longitudes of all the US states and grabbing them in this data frame, which we're going to use to do some plotting really quickly. And for the sake of time, I'm going to copy in some code that I have pre-written so we're able to see this visualization and make sure that we get to the forecasting that we have, since I want you all to be able to see this cool visualization, but make sure that we get to talk about that forecasting as well. I'm gonna do this only for Python or Java. So if you can do a quick shout out in the chat if you wanna see this, this map for Java or for Python, let me know, and we'll do the one that we're seeing we're getting more responses from.
Okay, we got a lot of Python here.
A lot of Python. Okay, so let's do this for Python.
Data scientists, I can tell. Python lovers.
Python lovers.
All right.
Okay. So what I'm doing here, this is some code that is taking this interest by region data frame that we had up here. This is interest by city now, but we're gonna take the interest by region data frame, and we're gonna do a few things to it quickly. We're going to create a new column based on the location, where we're just lowercasing all those values in that column. And this enables us to use this data in coordination with the state data that we downloaded from the maps package. So we can see this region column is all lowercase, but before our locations had a capital letter. So now we're just removing those capitals. So we're working in the same format. And then we're gonna filter our data frame to only have rows where our region, or state in this case, is one of the states that we have in this state table. And then we're gonna select just two columns to look at: the region, or the state, and the popularity, which is the hits. And we're gonna order it in descending order by hits. So now we see for Python, these are those most popular states. And now let's go ahead and create that visualization with Ggplot. So Ggplot is a package that is really amazing for doing visualizations in R. And it's, I would say, a really user-friendly plotting package. I've worked with matplotlib in Python, if any of you are familiar with that, which is also a really great and useful tool. But there is a little bit of a learning curve that comes with using matplotlib. In R, Ggplot is a little bit easier to get up to speed with. And don't worry if you don't recognize or understand this code I'm about to paste in right now. If you start going through our Learn R course, you can learn more about Ggplot and some of those functions. And we'll briefly chat about it and take a look at what's going on here briefly. But what we are doing is we are using Ggplot to add a few maps. So we see this geo map here on line 46 to 49 and 50 to 53. And essentially what's happening here is we are creating maps with different data. The first map we're creating is the actual state map, where we're using that longitude and latitude data to plot out the actual states. So we can see the shapes of them and visualize that. The next step is going ahead and adding in this popularity data that we have right here. So now we're saying on top of that blank map that we created, let's go ahead and fill in that information about which states really enjoy Python. And we've added in a few more things here that kind of change the axis so we can see the data more clearly, and that just change some of our labels so we're able to see them more easily. If we go ahead and run this data, we're now able to get this awesome map, which I want to expand for us all right here. Ooh, expanding the wrong way. Oh.
This is actually a really, and this is, I know some people were like Ggplot or matplotlib. And so this is actually a really easy way to be, to actually visualize the results in a map versus in a bar chart or in a time series. And so here you clearly see that the top hits are in California, in Massachusetts, and unfortunately in more states in the South or in Midwest it is less relevant, let's say. So I highly recommend to, when you are doing a lot of these types of data analysis, to think of a lot of the creative ways that you can actually visualize it, especially when you're, presenting to stakeholders or to leadership. It just summarizes so much in one easy picture.
Great. So I'm just looking in the chat to see if we have any questions here from anyone.
I really love what's happening in the chat right now. I think it looks like people are being pretty, thinking really critically about the data that's coming up. So, I really appreciate the, trying to understand why California being such a huge state. I don't know, I appreciate what's happening.
Mm-hmm. And yeah, these are the kinds of questions that are great to ask. The data helps us see what is happening, but then there's the question of why sometimes. And that's where it helps to kind of have some knowledge about the data that you're working with, or to have that background, because once you're able to see what is going on, you can use that knowledge to explain the changes that we're seeing and provide that insight. So great questions, everyone.
Also, I just have to, our data manager, our data team manager is hanging out in the chat and being funny. I wonder if you can spot her.
Yeah, total creds to her. She was giving me tips IRL.
Hey, Kat.
Busted.
Awesome. So now that we've gone ahead and done some of this exploratory analysis, seen our data visualized in different ways, let's focus in on the task that we have at hand, which is that forecasting and looking at our data over time. So to do this, let's look at our data frame of the interest over time. So we take a look at it here really quickly. We have a few different columns. We have the date, We have the hits, which is that popularity. We have the keyword. Those are the columns that we're going to be focusing on for this analysis. And so in order for us to go ahead and get this data ready for our time series, there's a few things we can do. Let's go ahead and do a little bit of data cleaning on this data. So let's take this Lang interest over time, and we are going to do some manipulation. So first, I'm going to pass this into a function called asTibble. And don't have to worry about this function too much. This is essentially just converting this data frame into a type of data frame that works better in the tidyverse. So it'll enable us to do some manipulation more easily and handle this data a bit better. And then we're going to do a little more data cleaning, where we're going to update our date column to a different date format, which will help us more easily plot and work with this data. And then in addition, we are also going to do a filter to only look at data that is occurring from at least a week ago and back. So we don't want to look at data from the last week. There could be some noise in that data. We just want to focus on data from before that time. So to do that, I'm going to say I want the date to be less than, and I can use sys.date, which will pull the current date. And we want to say that we want this date to be at least 7 days before this current date. And I'm going to save this to a variable Lang time series. Cool. And we have that. And I can also just showcase this to you quickly. And then we're going to do a really quick visualization on this data before we go ahead into our modeling.
We're seeing the requests to slow down a little. I think that Ian and Camelia are trying to make this a very action-packed 90 minutes. Yeah. Succeeding at making this an action-packed 90 minutes for you. This will be available as a recorded version on YouTube. And fingers crossed that this ends up in your email inbox too, since you registered. So you will find this again and be able to slow it down. Okay, I'll stop.
And the only reason I think we might be going a little quicker than we would want to is because we're just so excited to get to the forecasting and the time series part. So bear with us, we will get there.
Yeah, and it can definitely seem like a lot, and it is a lot if you're coming into this never having worked with R before. So don't feel bad if you're not understanding every line of code or what's happening. This will be like at least set available to you to take a look at later on, and you can dive into it and look back and see again what was happening. And thank you for whoever in the chat was posting that more information about the Google Trends data. I think that's really helpful for getting an understanding of what is happening with that hits or relative interest column. But essentially what I just did here was change the format of our date so it's easier for us to work with. And we're just looking at dates from a week ago back to 2015. So I don't want to look at this past week, a week ago to 2015. And let's do a really quick visualization on this data. So I'm going to take our Lang time series, and I'm going to pipe it into Ggplot. And with Ggplot, there is this weird kind of little different thing where we use this plus sign instead of the pipe symbol when we're piping our information into a different or the next function. In this case, instead of making a map like we were last time, we're going to make a line graph so we can look at this plot over time. And what we are going to be plotting over time is our date on the x-axis. And then we want on our y-axis to be that popularity or the hits. In addition, we're looking at both Python and Java here. So we're going to add one more parameter here, which is assigning the color to be recognized as our keyword. So we could choose to just plot the Python interest over time, and we wouldn't need to add in this color keyword if we maybe go and filter our data to just be Python. But because we have both Python and Java, we're going to add this additional keyword so it'll put them both in their own color. And lastly, I'm going to add one more parameter here of size equal to 1, which says how big do we want to draw this plot. So I'm going to go ahead and run this code, and we can get a really quick visualization of what this data or this time series data looks like over time. And so we can see we start, and maybe Camelia, if you want to jump into analyzing this for us.
This is, I think, where the core of the time series analysis actually begins. So what you'll see is x-axis, the date, which we've been pulling from Google Trends, and our y-axis is the hits. And so I think one thing that you would never have been able to visualize if you had just looked at this in tabular format is that overall the trend, which once again is a very key term in time series analysis, the trend for Java is decreasing, whereas the trend in Python is increasing. And you see that really starting around 2016, you're starting seeing this kind of shift where the hits kind of like bifurcated. And so that's when you can start developing a lot of these hypotheses. However, Travis, I think, has just mentioned it, which is no one is searching code on New Year's. As you guys see, these are cyclical trends, and every single year, starting December 20th or so, there's just this huge dip where people are just like, done. I'm not interested in programming. I just want to spend time with my family for holidays. And so this is something that definitely we will be able to replicate in the forecast, because this is a really core element of our time series. And then in terms of hypothesis, really, one of the reasons that you could potentially think about why the interest in Java is decreasing versus Python is increasing is that, for example, in data science, you start seeing that Python is a language that can definitely easily be used for so many applications. And then there's a lot of the core functionalities of Java that make it a little bit more of a tougher language to learn can be used with similar applications in Python. One hypothesis, but there's so many things that you can derive from this plot.
Great, thanks for that analysis, Camelia. And one of the things that I just want to go back to with Ggplot is in 3 lines of code, we were able to go ahead and create this plot, which I think is really awesome, really user-friendly. And even if you don't, know the Ggplot syntax at this time, that's totally okay. You can check out our course on Ggplot, which will go ahead and explain all the code that's here. And if you get to that lesson, you'll be able to create a chart just like this. So now that we have this time series data, we can move on to that really exciting part of modeling. And so a lot of people keep asking questions in the chat about, what is that split between cleaning and getting the data ready and the modeling. And so we're finally getting to that point now where we can do that model, make those predictions. And so we're going to do this using the profit package. So I'm going to create a new variable that will store our model. I'm going to call it Python M to represent the model. And I'm now going to use the profit function from the profit package. And I'm going to pass into it our time series data. And now there's actually one thing that I'm forgetting to do before this. We just want to focus on the Python data at this time and not worry about our Java data. So I'm going to do a really quick subsetting of our data and cleaning it so it is ready for modeling. So I take it back. There's a little more cleaning that we need to do in order for us to go ahead and make that model. So I'm going to take our lang time series and I'm going to filter it for a keyword equal to Python. So I only want the rows of our data frame where the keyword is Python. And then I only want 2 columns from this data frame. I want that date column, and I want the hits column. So we're only interested right now in like the date of interest and the level of interest on that date. And there's one more thing we need to do to work specifically with the profit package is we need to rename these columns of our data frame. Since when we pass this data over to profit, it wants the data in a particular format. Profit is picky, we have to appease it. So in order to go ahead and do that, we're going to rename our date column DS, which I can do using this rename function. And I say I want the new name to be equal to this old name. And then we want to rename our hits column with Y. And lastly, we want to go ahead and arrange this in order of date, just so we have it in that nice order of starting out with our oldest data, moving forward to our newest data. And we can go ahead and look at this variable as well. And we can now, or this data frame, we can now see we have this DS column starting from April 12th, 2015. And the interest in Python was 43. And if I go all the way to the end, if I click this 26 here, we can see that the most recent data is that week ago, or about a week ago, March 29th, interest of 75. So we see that general increase from 43 to 75 over the last 5 years. I'm now going to go and take that Python time series data that we have, pass it into our profit function. And when I run this, this is going to actually go ahead and create this model for us. If you're doing this on your local computer, the first time you do this, it might take a little bit of time to actually go and run that model. The profit package is doing a lot of stuff on the back end, doing some math, some calculations, building that model for you, and finding out kind of all that information that's hidden in that data. So it's recognizing, are we seeing a general increase potentially in our data, or is there that seasonality, right? That New Year's, dip that we were seeing, things like that.
And just remember that essentially what profit does is curve fitting. And so as Ian mentioned, it has to be able to capture all of these patterns and understand what are the underlying, what are those parameters in order to create the most robust forecast. So that's why you just have to be patient with it when it runs.
Yeah, great point. Patience, once again, a virtue of a data scientist as well. So the next step for us is to go ahead and think about how far in the future do we want to make predictions. And this is a good thing that you should discuss or think about and plan before you go ahead and start making predictions for 10 years into the future. I was thinking once when I was learning data science, learning that I could forecast things, I was like, okay, let me go grab some stock market data and let me go predict what's going to happen over the next few years so I know exactly where to put my stocks and I'll make all this money. Why is that maybe not a good idea, Camelia? Correct me on this.
Sorry, I was answering some chats. Can you repeat that, Ian?
No worries. I was just saying how when I was first thinking about forecasting and learned that I could go predict out or forecast things maybe a few years into the future, I was thinking about putting all my money into these stocks based on my forecast over the next 5 years or 10 years. Why is that maybe not a great idea?
Yeah, I mean, markets are very volatile, and you definitely want to just have a forecast as close to the present as possible, because as you keep extending to 2 years, 3 years, 5 years, you have less of an understanding of what happened in the kind of not only in the history in the last year, but you're just going to have like way more error and your residuals will keep growing. So definitely keep it in a very non-volatile market. So I highly do not recommend do not try forecasting commodity indices or anything relating to finance, and just 365 days. Anything past that, it's really just going to be a directional approximation at best. And yes, or oil.
Yeah, so we can make some predictions, but we want to keep them in that smaller range. Thank you, Camelia. So To go ahead and make a decision on how far we want to go and make these predictions, we use this make future data frame function from Profit. And what this will do is it will create a data frame of dates for us that will include the dates of our actual data that we have. So that past 5 years from 2015 up through last week. We're going to go ahead and then look another 365 days into the future. So we use this periods equals 365 keyword, right, with that value of 365 to say, let's look 365 days in advance. So I passed that with our model that we created into this make future data frame function. And let's take a look at what we get out of this really quickly. We see it just gives us this data frame that starts once again in 2015 of April. So like we saw that original 5 years ago. But now if we go to the end, it's taking us all the way through 2021, March 29th. So instead of being up to a week ago, we now have dates all the way to a year from now. Now we get to go ahead and actually use our model to make those predictions. And so to do that, we use a handy function that is built into R called predict. And the predict function takes any model that you've built and it applies that model to a set of data that you feed to it. So we're going to pass into predict our profit model as one argument. And then as a second argument, we're going to pass in our dates. So the Python present future. And I'm going to save this into a variable. I'm going to name Python future data. And let's go ahead and take a look at this as well. And now one more thing I'm going to do actually before I take a look at this data frame is I'm going to once again use that as Tibble function in order to make this data frame easier for us to work with. And now let's take a look at this Python future data that we have. There's a lot of great stuff in this data frame that we are going to use. So I think it helps to take a second to dive into it and talk a little bit about those columns briefly, since I know we are getting short on time. Camelia, do you want to take a look at, discuss this?
Well, I think one of the best things that we can do is why don't we plot this as a time series so then we can actually go through the, sorry, that was a lot of noise, but we can go through the lower and upper bounds and then I can explain to you what the trend and the additive terms are. I think that'll be way helpful than just looking at the data frame.
Awesome. Great point. Visualizations are always better than looking at tables. And so in order for us to do this, for the sake of time, there's a little bit of code that I'm just going to paste in here that allows us to do some data cleaning on this data frame. So what we are doing here is we're taking this data frame of predictions or forecasts that we made, and we are essentially saying, let's segment this data into what we actually already had, the real data from the past 5 years, and then data from the forecasts. So that next year out that we're predicting. And we just want to make that distinction there so we're able to plot those separately. And so I'm sorry that we're not going to dive into this code here. There's a lot of fun stuff that we could discuss, but I want to make sure that we get to that visualization. And now with this data frame, we can go ahead and plot this data. So what I'm going to do is I'm going to take that Python forecast that we just created, and I'm going to pipe it into Ggplot. And I'm going to add a few different geomes here to represent different things. So first, we're going to do a line graph of our actual data. So I want to plot the date versus, I'm sorry, our date here is DS. So the date versus the number of hits, which is our Y here. And then we're going to, and this will plot that actual data that we saw before in our visualization. So over the last 5 years, what is going on there? Oh. And if I plot that quickly, we can see that, right? This is the same data that we had from before, just for Python. Now let's go ahead and we will add in some code that showcases the forecast that we had. And also, since we have 8 minutes, I am going to just paste this in. Normally I'd walk through it, but I want to make sure that we have time to discuss the visualization, which is ultimately what we are all here to see. And I'm just going to make sure this is all good.
All right.
So let's take a look at this, because this is the big interesting result.
So this is really the final product, right? This is your forecast essentially. And so you'll see that the red part is specifically the part that you predicted based on those 5 years of data. You'll see that the shade, those are essentially your prediction intervals. So when you saw in that previous data frame, upper and lower, that's exactly what it was predicting. And that's just giving you a cushion of, based on the forecast, what you can expect that it won't go over and under. And yes, Travis, it predicted New Year's. And why is that? Because it is an additive regression model. It will predict your seasonality and it will predict your trend. And so your trend was that since 2015, it was increasing. And that is exactly what we are seeing starting 2020 at a different slope, but it's still increasing. Now, what you're seeing then it also predicts is exactly that seasonality, is that every single year in December, that, the usage or the relevance of that programming languages dips. And that's exactly what it's doing. So really, this was just a really great example to show you how, first of all, robust of Prophet is. It's a really excellent forecasting package, but it also really analyzes the data in order to come up with the most accurate and robust prediction.
Great, thank you, Camelia, for that explanation. And what we're even able to do with the Prophet package is dig a little bit further into what is going on in terms of that seasonality that we were discussing and that trend. And we're able to do that using this function Prophet plot components. And if we pass into this function our model and our forecasted data.
This is what I love the most, because it was one thing for me to just do that voiceover on like how I would interpret that prediction, but Prophet once again here extracts the seasonality and the trend component of that data set, of that time series, and tells you exactly what I was just saying, how starting 2015, that trend, it was an increasing trend, but it was increasing more slowly starting 2019, right? That's something that we were also seeing in the prediction. And then can you scroll down a little bit, Ian, for the yearly, for the seasonality? Yeah, so that's exactly what you see starting, even before November. Yeah, I think that's about Thanksgiving, actually. Starting Thanksgiving, you start seeing that the hits of Python just decreases dramatically. And now this is all cool, and I love it. Once again, if you're interested in this type of stuff, if you want to understand how a model works, these are some really cool trends to be able to understand. But why is this even more relevant in, let's say, in an operation or in logistics or in supply chain? Because when you're actually trying to say, okay, like I need this number of supply for the month of November, well, you're going to use your historical time series to be able to say, well, between September and November, my supply is always between X, X amount and Z amount, which this is where the confidence intervals come in, and you're really able to have a stronger, more solid understanding of your business if you're able to understand these seasonalities and trends. All you, Ian.
Awesome. Thank you for that explanation, Camelia. And now what we can do quickly with our few remaining minutes is take a look at our Java data. And I'm just gonna go and paste in a bunch of code here that's essentially replicating what we were doing earlier. But it's gonna enable us to go and look at both our Java and Python together. So I'm just gonna grab this. And let's run some of this code. So what's happening here is we're creating that time series for just Java, like we did with Python. And we're going to go and build our model for Java, make those predictions on, or those forecasts for the next year. And we're going to do a little bit of data cleaning, segmenting our data into the data that we already have versus what our forecast is. And now we're going to go and combine that forecasted data for both Python and Java into one data frame. And then we can go ahead and plot it all together. So now we can see what those Google Trends look like over time for the past and for our forecast for both Java and Python here. So what's the outlook for Java, Camelia? Are we going to see a Java resurgence?
I don't know. It's just, this graph does not give me much confidence. I will definitely say that it's at best staying at the level that it was in 2020 with similar seasonality for Christmas 2021. And Python is going to keep increasing, which I'm very excited to see.
Yes. Seems like Python is having a good moment. I'm interested to run this analysis on R and see how R is doing. My gut says that R would also be seeing a similar increase with Python, with data science becoming more talked about and more popular these days. But we'll have to do some coding and find out.
Totally. And guys, I know we covered a lot of material, but definitely try to rerun parts of this code, play around with different keywords, play around with different regions, do the question mark profit, question mark Ggplot2, question mark whatever, and really learn about your packages, learn about your tools, learn about your methodologies, because as a data scientist, you're really only as good as your toolkit. So really and don't be afraid. That's really my biggest recommendation.
Yeah, go out, explore, find data that interests you. And if you're not sure where to get started on this whole journey, the Learn R course that we have on Codecademy is a great starting place. We highly recommend it. And it's a great place to get your feet wet. So don't be scared. Keep asking all those questions and you'll have a great time.
And really the last thing that I will say, because I know in every intro to programming courses, your professor, your teacher will always be like, you can't break it. You're not going to break your computer. And that couldn't even be more true for R. You will never break anything. So just go ahead, be crazy, be ruthless, and just practice makes perfect, right?
Yep, give it a shot, give it a go. Nothing you can do will be wrong. It's all learning journey. So I hope everyone had a great time today. I posted a link in the chat to download the code. We will also place it on the site for you, so you can be on the lookout for it there. But once again, I'm going to paste that link one more time if you want to go ahead and download that code. So feel free to just go and download it right there. Thank you all so much. We have a wrap-up session that you can move on over to hear some closing remarks from our day of code. And I'll hang out around here for a little bit and try and answer some more questions just in the chat. But thank you all so much.
Yeah, guys, you're the best. So fun today. Thank you. Bye.
Bye, everyone. And everyone who's still here, I'm looking for the link to send you all over to our closing remarks. Okay, everyone, I'm about to post in the chat the link to the closing remarks. Feel free to check it out. Thank you all. Awesome. Thank you, Raneem, as well, for posting that there. You all take care. Have a great day. Yeah, feel free to reach out to us on, the internet, LinkedIn, things like that. And happy to chat more. Take care.